Okay, so I just want to look at packs of cards and just make sure you realise how many are in each. So in a pack of cards we have 13 hearts, 13 diamonds, 13 spades and 13 clubs. The hearts basically look like hearts, the diamonds like a diamond, the spades look like that, and the clubs, well, they look like a club, okay, like a three-leaf clover. Okay, so of the hearts, all right, we have, like, you go ace, and then you have 2, 3, 4, 5, 6, 7, 8, 9, 10, and then it goes, then you have your picture cards, which are your jack, queen, and king. And you do the same for all of these, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. A, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. And ace, 2, 3, 4, 5, 6, 7, 8, jack, queen, king. Okay, there are 4 of each type, so there are 4 aces, there will be 4 twos, 4 threes, etc. So there's 4 of each one. Okay, so we're just going to look at a question on probability to do with cards. Okay, so looking at this, and a card is randomly drawn, so only got one card. What's the probability that it is a heart? So that's 1/4 of the pack. So 52 divided by 4 is equal to 13. Okay, so it's 13 on 52, or you could think about it as just being 1/4 on the pack, because 13 on 52 simplifies to that. Okay, B, so we want a heart. So there are actually 13 hearts, or we want a king. Now, there is one king that is a heart, but then there are 3 other kings, so that would give you 16. So that'll be 16 on 52, which will simplify to 4 goes into that 4 times, and 4 into the other one, 13. A queen of diamonds, so that's only a queen of diamonds, that's only one card, so it's 1 in 52. Not a diamond, so not a diamond. You could do 1 minus that it is a diamond, so 1 minus it is a diamond would be 1 minus 13 on 52. So, or you could just do 3 lots of 13, which is 39 on 52. Now 3 goes into that, no, won't go, so that's it. A red jack, okay, so it's got to be red and it's got to be a jack. There are 2 red jacks because there's a heart and a diamond, so that's 1 on 26. A queen, so there's 4 queens, or a red card, so there are 26 red cards. Okay, the problem is 2 of the queens, the heart and the diamond, are counted in the reds already, so it'll be 2. So it'll be 2 plus 26, which is 28. So that is 28 out of 52. So 28 out of 52, what would that be? 14 on 26, which is 7 on 13. Okay, so now I'm just going to look at a bag of marbles. So a bag of marbles contains 5 times more red marbles than blue marbles. So that would be in the ratio of 5 to 1. So that would be like red to blue. So a marble is drawn at random. What's the probability that it would be blue? Well, that would be 1 in 6. Okay, let's just look at children. So they have a 50% chance of getting a girl or a boy. So if you have 3 children, so you you could have boy, boy, you could write them all out. Boy, 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 girl, boy, girl, boy, girl, boy, boy. And then you could go for the girl, girl, girl. So you go girl, 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 boy, girl, boy, girl, and boy, girl, girl. So that's 8 possibilities. You could have figured that out without doing it, because it's 2 times 2 times 2. 2 2s are 4, 2 4s are 8. So if we want them all to be boys, so that's only one way of doing that. You could think about that as 1 in 8. You could also use that multiplication principle. So you could go the probability of boy, boy, and boy. That's the probability of a boy times the probability of a boy times the probability of a boy, which is a half times a half times a half, which is 1 in 8. Okay. Now, looking at the second one, 1 boy and 2 girls. So you could list all this out. We could do 1 boy and 2 girls. That would be 1, 2, 3. So that ends up being, so that's part A. For part B, that ends up being 3 out of 8. Now, you could also, without doing that, you could have just listed all of the possible outcomes. Okay, so you could go, all right, one boy and 2 girls, and then think about all the different ways of writing that. So when I do this, I just move the boy along the line. So I've got the boy you see in the first place, then put him in the second position, and then in the third position. Because it's important what order in the family you're actually born in. So if you didn't write it all out and you use this, you'd want probability of a boy and a girl, plus the probability of a girl and a boy and a girl, or the probability of a girl and a girl and a boy. Okay, so it will be a half times a half times a half, plus a half times a half times a half, plus a half times a half times a half. And when you figure all that out, see it's 1/8 plus 1/8 plus 1/8 for each of those, which is 3/8, which is the same as what you get is if you list them all out and you see that there are 3 different possibilities. Okay, so if we look at least one girl, the easiest way of doing that is to do at least one girl is to do 1 minus the probability of no girls. And no girls wouldn't just be, it's not just on one outcome, it's on the whole event. So it's the probability of a boy on the first, a boy on the second, and a boy on the third. Now the probability of 1 boy is 1 in 2, because you get a boy or a girl on the first one. On the second one it's 1 in 2, and on the third it is 1 in 2. So it's 1 minus 1/8, which is equal to 7 over. So I'm going to make that a little bit neater. So you end up with 7 over 8.